Yeah.
Okay, we should be on. Okay, welcome on our 12th class. As standard, put your tick on your name so we know that you were here. Oliver today is off, he's under the weather. So he will be following us on YouTube and answering questions. So basically, he didn't want to sell the mantra to you. Thanks, Tristan, for leading the class, obviously. Our class is weekly, just a reminder to everybody. You can join us here or over the internet. Please RSVP for the at least next 2 classes. So the more classes we have reserved, then it's a bigger chance we'll get a bigger room rather than just being stuck here. I have new bunch of licenses from Phil, so whoever requested the license, I will be able to email you a copy. Website. The good news is we have finally somebody who is doing it quite seriously. It's Oliver, and he's doing quite well. So that's a good thing. And obviously after a class we're going to pub where you're very welcome to buy this guy a beer.
I don't think I'll go to the pub today. But
Okay, so you can buy.
I will accept a beer next time.
Yes, for example. Yeah. So well, that's basically where we are. So that's all from me, and I'm passing to Tristan.
All right. Yeah.
Be careful of the whole thing again.
Yeah, sure.
Okay. Well, good evening. First of all, apology. Oliver's off sick today. I've been under the weather the last few days as well, not been on top of the world, so a little less prepared than I would normally be. So apologies for that. I will get through it though. Don't worry. Just won't be going to the pub afterwards, so I won't make you walk. Normal thing about feedback, we do like to hear from you. I think everybody here has been to the sessions before. I'm sure I know. I haven't seen you for a while, but yes, a couple of people have been coming for a long time. But yes, please do join the Slack channel if you haven't already. Again, standard opening. You've probably all got a copy of this already. We're not actually going to be using it today, but it's generally a very useful thing to have. So today, what we're doing, we're going to start off a bit of revision from last week. Covered a lot of material last week. It was a pretty hardcore session, so we'll go over a few things again today for the first 15-20 minutes or something. So if you have any questions from last week's material, a really good time. We're going to go on to talk about special member functions, so constructors, destructors, assignment operators, all those kind of things. And then, if we have time at the end, we'll talk about member access, so public, private, protected, and this mysterious class keyword that people were nagging me about last week. So, I'm really excited to learn about classes, and probably going to be quite disappointed to learn they're exactly the same as structs. All right, does that sound good?
Yeah.
Awesome. All right, so from last week, structs. A struct is a way of defining a new data structure, introducing a new type. Right, so we have a load of built-in types, we have ints, floats, bools, etc. We can define our own data structures, and we do that using the struct keyword or the class keyword. They do almost exactly the same thing, the only difference is in the defaults. So anytime you have a struct, you can use class and change the defaults, and vice versa. They do pretty much the same thing. So what is a struct? Well, it's a collection of member variables, which in other languages often get called fields. So this is the data that is inside your object. And we also have member functions that usually operate on those data members, operate on the member variables. Call them member functions. Other languages call them methods. Java, for example, call them methods. C++, the technical term is member functions. I'll often call them methods. So if I say that, that's what I mean, member functions. And we create an instance of a struct using exactly the same syntax as we do for built-in types, like ints and floats and the other things you've already seen. So we declare our familiar struct point. It's got two member variables, x and y, both of type int. And now we'll create an instance of our point, call it p1, and we haven't initialized it with anything there, which means both members get the default initializer, so they're both initialized to 0. And we'll create another one called p2, and this time we've given both our members explicit values of 1 and 2.
The struct, is that necessarily always in the header? And then the point in
The struct will usually go in a header, because that way you can reuse it in different implementation files. So occasionally you'll have a struct that's just private to your implementation file, that's not used anywhere else, but most of the time your struct definition and its member function definitions will go, sorry, not the member function definitions, member function declarations will go in the header.
Okay.
All familiar from last week? Yeah. If there is anything that's not, then yell at me. So, just talked about the member functions or methods. They're functions which belong to the object, belong to that type. They operate on the member variables of that function, of that struct. I'm not sure if I mentioned this last week. I think it came up in one of the exercises. But within the member function, within the body of a member function, we can access the instance that we're operating on using the keyword this. Now, as a sort of historical relic, this happens to be a pointer. It's a pointer to the object we're operating on. Right? It should be a reference, but it's not, and it's silly, but we can't change it now because this decision was made 35 years ago, so we're still having to deal with it. But this is a pointer, which means that if you want to use it to access your members, you have to use the arrow rather than a dot like you would for a reference. But once you're used to that, this is the keyword you use to access the instance that you're operating. So another bit of terminology, we talk about member functions. We also have non-member functions, so those are the ones that we were dealing with prior to last week. All the normal kind of functions that are outside of a class, outside of a struct. They're called non-member functions instead of member functions. We also call them free functions sometimes. So if you hear that terminology, that's what we mean. And this is the thing that we spent a bit of time talking about last week. It was a bit confusing. We can add the word const to the end of a member function declaration. And when we put that keyword there, that means that member function is guaranteed not to mutate, not to change any of the member variables. It's a promise that we're not going to change any of our member variables. And that means that member function can be called on a const instance of that struct. Right, so if we had, on the last example, on the last page, we had this struct point. If I had instead here said const point p1, then if we wanted to call any member functions, not that we have any member functions yet, but if we did, I could only call const member functions on that const instance. So const is one of those things, const member functions are one of those things that seem a bit weird to begin with, but then after you've used them a bit and used const instances, it becomes a bit more obvious when to use them and when not to use them. Oh, so you're looking very relaxed at the back there. You've got a comfy seat. So that's what I've got to say about structs. That's last week's session condensed into 7 minutes. So that's pretty good going. So are there more more questions from the portion last week talking about structs.
I was going back to this keyword.
Yeah.
Is there anywhere where you have to use it? Because I noticed last week I've got a thing saying, don't really need this. I don't really need this.
Okay,
You know what I mean?
there are two things where you need to use it, right? So the first is if you do something a bit silly, and that's if you've got a member function that takes arguments, and you name one of your arguments the same as one of your member variables.
Oh,
Now that's a bad
yeah,
idea, okay? But you can do it. And if you do that, let's say you've got a member variable called x, and one of the arguments to your function is called x. Within the function, if you just say x, it's going to refer to the argument. If you say this arrow x, it's going to refer to your member variable. That's generally seen as a bad thing to do. Don't repeat the names. What people often do is either add a prefix or a suffix to the names of their member variables. So you often see like m underscore, whatever it might be, data. Or data underscore is another common one. So that if you're just looking at a member function definition, it's obvious which are the member variables. So it's just a kind of, I guess, notational convention that people use. The other time, so that's one of the two occasions. The other one is when you're doing really complicated template stuff that's pretty advanced, and then so don't worry about that one. You wouldn't come across that one for a very long time yet. Do you know about that one?
Yeah.
The other time you have to use this, yeah.
Yeah, especially in the knowledge set.
Yeah. Yes.
Okay.
Any further struct questions? Awesome. I actually did a better job last week than I thought I did. Cool. Right, so let's talk about operator overloading.
Sorry.
So, for our built-in types, we can use a sort of almost mathematical syntax for dealing with them. We can say, if we have int I and int j, we can say, is I equal to j? So we say I equals j. And that will return us a bool that tells us whether they represent the same value. We can say I plus j, and it will give us a new int that's the two things added together. For our own types, we want to be able to do the same thing. And the way we do that is by defining what those operators mean for our types. It's called operator overloading. Hello, come in. Pop yourselves. Oh, maybe. So, for example, we can say int I equals j. Well, we'd like to be able to do that for points as well. We've defined our point class. We're going to be reusing this point class all the time today, by the way. So we can define an overload of the equals operator that operates on 2 points. Now, equals is what's called a binary operator. That is, it takes 2 arguments. And here I've called them LHS and RHS, so left-hand side and right-hand side. Returns a bool, which is obviously what we want. We want to say, are these things the same or are they not? So this is the declaration of the equality operator. And then our implementation, if you remember, we had 2 members, x and y. So we say, is LHS is the left-hand side's x, the same as the right-hand side's x, and left-hand side's y is the same as the right-hand side's y.
Can you do this as a free function or only within a split? Or a
Good
class?
question. Here, I have declared it as a free function.
Right.
Now you can also implement it as a member function. But if you implement it as a member function, it only takes 1 argument. right? Because if you think about it, a member function always operates on the instance. So your left-hand side is already defined. It's this. It's the thing you're operating on. And the right-hand side. Now, whether you choose to do it as a member function or as a non-member function, it's kind of a matter of style. There are a few operator overloads that must be member functions. I can't remember what they are off the top of my head. The square brackets, assignments, maybe the arrow operator, I can't remember. There are none, as far as I know, that must be non-member functions, but conventionally, equality, inequality are non-member functions. The assignment ones, so plus equals, minus equals, those must be member functions as well. Because if you think about it, they modify the thing they operate on.
Yeah, of course.
Yeah. So yes, that's a good question. So yes, this is the syntax for implementing an operator overload. And almost all the operators in C++ can be overloaded. Right? We saw there was a big list. Can't remember how many of them there were last week. Loads and loads. Pretty much every bit of punctuation you can imagine, right, can be overloaded. So the question then becomes, well, which ones should we overload? If we've got a custom type, if we've got something like our point class, what should we implement? And the answer is those that sort of make sense. Right? So does it make sense to implement the modulo operator, the percent? Well, it makes sense for ints. It probably doesn't make sense for points. Or more familiar example, multiplication. Multiplying two ints is fine. We know what that means. What does it mean to multiply 2 points? Well, it doesn't really mean anything. Now, you can make it mean something. You can make it mean whatever you want. You could make point A times point B fire the missiles, as they say. Right? You can make it do whatever you like. But that's going to be really surprising to anyone else who uses your point class. Right, so one of the things that in other languages, not all languages have operator overloading. Some people say, oh, well, it's really kind of you're hiding this in kind of cute syntax, syntactic sugar, and it's hiding what it's really doing. But we could have a function called add that adds 2 points. But equally, you can have your function called add that fires the missiles. So just because it's called add doesn't, well, that's my argument in favour of operator overloading anyway. So be sensible with operator overloading. It allows you to do absolutely crazy things. But don't do crazy things. Be sensible. If in doubt, do what ints do. Right? Only implement those operations that make sense. So we went through the list for points last week. So the ones we decided made sense for a point. Can anybody remember?
I think we decided addition.
Yeah. There's one before that. So we decided, I've decided, equality makes sense.
Yeah.
So if we've got equality, we really want
Inequality,
exactly. If you do one, always do the other, right? Because if you can say, is A equal to B, you really, really need to be able to say, is A not equal to B? It's going to be very surprising if there's one and not the other. So if you do equality, always do inequality. If you do plus, normally need minus as well. Not always, but just, as I say, be sensible. Right, so yes, equality, inequality, addition. Subtraction, yeah, you can subtract 1 point from another. A couple of others.
Division.
What does it mean to divide 1 point by another?
Well, we will have 1 point there, 1 point there. So if you divide, we'll get something in the middle. Yeah.
That's not dividing 1 point by another, though, is it?
But that's, I mean, it could be understood as,
It could be seen as a vector, like a mathematical vector.
Uh-huh.
in which case scalar division might make sense, scalar multiplication might make sense, but probably not division by 2 points. Okay. Oh yes, that brings me on to something I neglected to mention. Here, we defined an equality operator that has a point on the left and a point on the right. We can actually have any old type we like on the left and any old type we like on the right. They don't have to be the same. So if we wanted to, if instead of point we called it vec2d, right, a 2D vector, mathematical vector, not a standard, a mathematical vector, then we probably want to define scalar multiplication. So we might have an operator times that took an int on the left and a vec2d on the right. And then, if it was a vector, then scalar division would make sense. So we'd have an operator slash.
So what is that? That's multiplying both properties of the point by the end that you.
That's what you scalar multiplication of vectors. Again, and we'd implement those because if you have a mathematical background, those are the operations that make sense for a vector. So yes, going back, the operators that make sense: equality, inequality, addition, subtraction, plus equals. So addition and assignment in one operation. So for an int, you can do I plus equals 3. We'll add 3 and to that vector, change the value of that vector by adding 3 to it. We could probably do that for points as well. Plus equals and a corresponding minus equals. And then the last one that violates this rule of doing what ints do in their operators is this output streaming. So cout has these funny operator overloads that let you stream to the output stream. Move the type, copy the type into the output stream, print it. That's how you do standard cout, arrow, arrow. It does that by defining a load of operator overloads. In complete violation of this advice. But again, it was written in 1983 or something, so this advice wasn't quite as ingrained at that point.
Yeah, but you can use stream operators with ints.
Yes.
So how does it validate the entry?
Because if you have an int on the left and an int on the right, what it does is bit shifts. So the double arrow means bit shifting for ints. But for an output stream, it's overloaded with a completely different meaning, which, yes, is a bit strange. But again, it's been around for a very long time, so we're sort of used to it now. So we can implement this streaming operator for our type as well. I did put up an example of that last week. I don't blame you if you don't remember it. But the bad news is you're going to have to work out how to do this again right about now. So we have a little exercise that we didn't get around to last week. I've sort of modified it a bit for this week. So if you go to that URL, which is a bit small, I'm afraid, then it will have a little repository of starter code in which I've already defined the equality operator for you. And your task is to implement a load of other ones. Now, I realise this is a bit small, so this one I made earlier. Word wrap. How do I put word wrap on? Does anybody know?
You have to get options, I think.
No, because this uses a funny. Oh well.
It's in the window, I think. Which? C. Q. X.
It's about the best I can manage.
Attackers might be trying to steal your information.
Well, actually, if you think about the number of programmers in this building, then maybe. Sorry? Go to that URL. It should give you, it should tell you how to check out some code and create a new repository on GitHub. Well, I can read it out to you if you like. Or
Could you post it in Slack?
could I post it in the Slack? Yeah, I can do that. That's a good idea. Oh, Ollie's way ahead of us. First time for everything.
I won't let me load it. I cannot visit GitHub right now because HSTS network errors exactly.
Seems like something odd with your. Are you logged into the Slack channel? Because if you are, you should just be able to copy the link.
No.
Or can you access any website? That's the first. Oh, okay.
Yeah, everything was here. Yeah, it's just sitting on importing complete. It's just, yeah.
He's got the same.
It's up there.
It's on the Slack, yeah.
I'm on the right page.
Yeah, are you logged in to GitHub?
No.
That's yeah.
Ah, there you go. Works now. He's waiting for a partnership to set up.
Yeah, I'm getting the same thing. I don't know why this. Okay, if you want to do it the old-fashioned way and you don't care about this fancy GitHub classroom stuff, if you look on the Slack channel, I've just posted the link to the bare repository, so you can just clone that one if you want to do it the old school way. The channel name is catchy. It's UG_UK_CPP London Uni. Yeah, GitHub Classroom clearly isn't wanting to work for us today. We managed to get to the second thing on.
Slack in
Yeah, I think the Wi-Fi is just being extremely slow here today.
Yeah, it is.
a lot of people.
Because it shows on YouTube when it's red every so often.
Did you manage
It's orange.
This is the exercise. Oh, you got. What's the address?
Oh, so did you get onto the Slack? Yeah, because
Confused when it's on Slack.
yeah, so it's just github.com cpp/cpp London Uni /week 12 _point exercise.
If you go to CP London, you find the folder directly.
Yeah, just go to the CPP London. Just go to github.com /CPP London Uni and search for the repos. Yeah.
Link in there.
Do you know how to change structure?
When it's what?
Yeah.
Yeah.
See, what do you have to do?
Implement operator not equal to.
Plus.
Now you should open the CV file here.
This one. So it's just git clone, isn't it?
Yeah, so on the, if you've got to the second, to the repository page, there's a green button on there that says clone or download. Oh crap. I've got something.
So we don't need to fork.
You can fork it if you want to upload your own solution later. Yeah, I don't know what went wrong with the GitHub Classroom today. Sorry about that.
Do we have to return for the plus equals? Do we have to return a new instance of a point? Is that? I'm confused about that.
Yeah.
Just type it in.
Yeah, that's not.
This one doesn't understand the CV. The other user.
Is this the week 12 point?
Week 12 point exercise, that's right, yes.
I don't see anything that needs to be done.
No, I didn't put anything in the README. It's on the screen.
Is it possible for you to kind of paste that into the slide?
I'll tell you what, I will put it in the README now. Just give me a second.
Is there a readme? There is no readme.
No, there isn't. It's because it's going to be more than one exercise using this code. So this is only the first.
Is it up to us what to do in this binary operator case? Just make something happen, return another instance of point or something. Return error, return a...
So for which one?
for implementing a binary operator.
The operator plus and minus.
Any particular thing you should do?
There is, yes.
Yeah, okay, right.
Part of the exercise is deciding what that right thing is.
Right. It's just I was going by what you said 5 minutes.
The reason I said binary operator plus and minus is because somebody, I can't remember who it was, but somebody pointed out last week that there is a unary version of operator minus that you can overload as well. So for example, if you have an int that's I, you can say minus I, which will give you in the negative of that. So you can overload unary minus as well.
Right. That should be a bonus.
It should actually, yeah.
Christian, have you seen your new photo?
My new photo. Crikey.
Mine one is very charming.
Helmut Kohl? Oh no, you're not. I'm surprised he didn't put Bryan Cranston on there. Okay, should be back on. Okay, if you look at that repository again, I've added a README, so it should be. Wow. Enjoy is a bit strong.
Yeah, I do. Still need to say something. I need a file. Like you mentioned. Yeah, the name.
Yeah, I did say it was harder. Well, you should all have a textbook with you, right? And you have access to the internet.
question is whether isn't it you return a string, or you could return characters. No.
So the output stream operator, as its left-hand side takes a reference to an output stream, std : O stream, and as its right-hand side operator is the thing you want to print. So in this case, a point.
So it's a dereferenced address.
No, it's a reference. And then it needs to return a reference. It needs to return the same O stream that it received.
So basically, it looks like the plus equal operator, but instead of having the point on the left side, you have the O stream on the left side.
Okay.
It takes the O stream and then the point, and it prints whatever you want to do.
So you can't just pass the memory address to the string, the first character of the string, and the length of the string, and just print the characters out.
It doesn't really work that way. So when you do this, you know the C out,
Yeah.
and you print whatever you want. You want to do like C out, shift, and then you point right, and you want it to print like X equal this, Y equals that. That X equal this, I would put that is what you do within the operator itself.
Yeah.
But the argument that comes into the operator is the stream that you want to print.
Oh, I
to.
see. Okay. 'Cause
Yeah,
I'm just thinking in the what's inside the string.
Oh yeah.
But,
No, but
it's not, is it? Because sorry, it's
No, you only
it's
get
the whole C out. It's got to cover everything.
yes. But within the operator, you can print some string and format it however you want to make it more readable.
Yeah. So, but okay. So this is just referring to the.
You could choose whether
So
you want to do it
that
as a member
argument
function or
point.
as a non-member function.
Yeah.
Otherwise, it gets very complicated.
Yeah. If you haven't overloaded this operator and you're trying to print it, you'll get the compilation.
So
That's
if
it.
you
Yeah. No.
Well,
Okay.
yes.
Yeah. No. I was thinking of.
If
I was
you do-
thinking
So there's like that kind of operator is overloaded for basically
Yeah.
all the
Also, if it's a
standard
member.
types already.
So
Yeah, yeah,
well,
Integer.
Yeah.
What
I
it's-
know,
so
I had the wrong end
so
of the- yeah.
if we have I plus j,
But
what
since
that
your
returns
point
it
is
doesn't modify
two
or
integers,
j, it returns you a
you
new
can
integer that is
do my point dot
has
x
the value of those
and
two
then
things added together.
print that. My
So
point
we
dot
have
y
to
and print.
from your plus and minus.
You can print each component. That stuff is already implemented in the cout string.
Okay, so you could use that inside your function to the. No, for some reason I immediately think I had to start printing strings out. So I was associating that with
no.
printing something
Yeah. No, it
in quotes.
it converts it to string internal.
Okay.
But usually you want to print some string maybe like brackets around and you print x, y, comma in between, and that comma is a string.
Yeah. Yes.
So don't come early today,
Yeah, I'm not going to the pub today.
but tomorrow.
Tomorrow, hopefully I'll be feeling better, and after my talk, everybody will want to be buying me a drink after my talk tomorrow.
That's the one that you sent you. I see. I think I understand the Gmail format is really confusing. You just attach it. Yeah, I just attach it to the file.
Yeah, the other reason I'm going home early is because I still need to write slides for my talk tomorrow.
Yeah, that's one.
Yeah.
I had the same both years now on my conference. Like 15 minutes before the talk, it's like, yeah, last slide, done.
Yeah, but here I am writing slides for what I'm going to say later. Now.
Yeah.
So.
But you can also see in my, at least in my slide deck, like the first slide was like super fancy, that, and it's like worse than the last one was like a stick figure, and then I'm done.
It's here actually. So the main C++ London meetup is here tomorrow, and
Probably upstairs right in
I don't know which room we're going to be in. But anyway, there are two talks. I'm doing one, and Phil Nash is doing the other. Well, hopefully not, because so far I think about 120 people have replied. So I'm not nervous at all. Might be a bit nervous.
And it's not a complex.
Sorry?
And it's not a complex talk either. Like everyone that is there, I think ranges is one of the most interesting things that we're gonna get in C++.
Well, hopefully people find it interesting.
Yeah.
So there are really two ways to go. Either you want to do a talk about something easy, so that there's no chance of you making mistakes, or you want to go something that's super advanced, so that people don't notice the mistakes. The trouble is, range is a lot of people are going to be familiar with range v3. So if I do anything wrong, it's just the wrong level of difficulty. Yeah, I should really do what Vittorio does and just do really, really complicated talks. Nobody.
But I think the hard thing is to have a complicated topic, but
explain it
simply for people that isn't like super advanced.
Yeah, I was. It's a couple of months ago we had C++ London, and there was a talk about the standard algorithms, and I said something about range v3. Everyone's what? What's that? So that's what prompted me to say to Phil, "Oh, I'll do this talk." And I was going to do it last month, but then we had what was his name? Guy from the Standards Committee came and did a special talk. So
I wasn't there last time.
No, it was out at Canary Wharf.
Yeah, interesting.
Wow.
Actually, both talks are interesting, especially this Phil's talk.
To be honest, I'm more interested in the second one because that seems really exciting.
Yeah, I sent it out to my colleagues because we don't use exceptions, of course.
Yeah.
But we
have you read Herb's paper? It's quite long.
I have it here.
Oh, right, yeah.
I started to read it before the class started.
It's basically the way Swift does error handling, I think.
Yeah.
But it
does make
like
sense.
return codes, but built into the language, which means that it can get more optimizations. You done?
No, not quite. I don't think.
This is the hard
this
part
is
about
compact, isn't it?
Yeah.
So what I've got is this is I did this over the weekend, so I'm being super fast. But I'm just putting this in here
Okay.
as a standard return,
Okay.
declaring it here.
So if you go back to your streaming operator.
Which was this one.
Yeah.
Can I not use? I can use the standard input output to to just output each
So
element.
is that a member of your point class?
P. Yeah. So I'm using my one I was doing. So point is a P.
Yeah. Well, wait.
Okay.
When you're testing it there, so if you hover over it, it's giving you a red line, which is a sign that something's wrong.
Yeah, exactly. But
Okay, so what? If you think about it, you've got an operator there, which is the arrow out, and on the left is cout,
it's the standard iOS stream.
which is a standard O stream, and on the right is a point. So you need to write an implementation of the arrow operator that takes an O stream on the left and a point on the right.
But this is the O stream on the left,
Yeah.
out,
Yeah.
and that's Basically, what I'm trying to do is the same as what I did with the plus and minuses.
Yeah.
So I need to do CAX A dot Y.
Well, you can do that, but that's what I wanted you to do was to write an operator overload so that you could just send a point. You didn't have to individually send both members.
Okay, right.
So we want an operator. So if you, it's gone from the screen, but if you remember the operator equals, it had two arguments. There was the LHS and the RHS. So you need to write a function that takes an O stream on the left and a point on the right.
So I need to do it out. Do I need to do it outside of the member function?
Exactly, yes.
Pointer.
Because I did the plus and minus one inside.
Sorry.
So on the left hand side should be an O string, on the right hand side should be a pointer.
A point.
What's the
So it should be a it should be a reference to an O string, not a.
IO string.
So I need to pass two arguments, basically.
Yes, precisely.
And that should be quite straightforward.
Yeah, that will work because you can take an int.
Yeah, it doesn't work with the whole
That's
thing
the
about,
And it will be
the whole exercise. Oh, the bonus.
I've got a problem with my plus equals at the moment, so I'm just trying to figure out exactly what it is. So I need 2 is my point calculation one. Oh no, one.
Do you know how to use Windows 8?
Sorry?
Do you know how to use Windows 8? But even then, why would you use Windows 8?
Yep.
For 2 years.
Yeah, mine is
really
like
Windows 10, so.
Okay. This is how. Okay. So.
We're using Windows 8.
Wait.
Maybe you're
Oh right.
Yeah, copy paste there.
There we
Or do you not have a laptop? No, this is oh, I see. I thought that was yours.
Right. So now we can get this back. So it should. Yes, that's better.
Oh, this is
So you want to for a third way, you can just do
Give you a black
shift P5.
Restrict it. Well, I need to do the. I need to make sure my minus equals works, and then I'll do that.
When you go for it,
Just doing the exercises.
Yeah, welcome.
That's not really right.
Yes, sorry. I didn't know.
Here.
Yes, obviously you're getting headed into Scalar, so you know exactly what
So much people from I've actually worked with Tottenham from that Tottenham portal to
Okay, that's fine. So obviously,
Cranley.
but the good news is all of our previous slides, so all of these we've done before. All of that's on GitHub. So if you look, there's a repository called Course Materials May 2018. So that's got all the slides from the previous.
Oh, yeah, fine.
And also, if you want to, all the talks from
YouTube, but like
so you can go back.
the numbers fluctuate, and I don't know
Spend
whether this is
a
the
few evenings watching those if you want to.
if something disconnects,
Obviously, the
and
session's
goes
running
to
through
you,
half
or
hours,
just
it's fine.
disconnect them for a second.
A lot of pairing exercises. So if you want, you know, of course, you're more than welcome to. You might find it a bit difficult to if you haven't followed them so far. But if you want to It's awesome. We're actually in the process of trying to put together a few YouTube videos to help people in your situation to catch up. We haven't quite finished on it. But we do have all our talks, all of these we do.
This exercise with the point is
So for C-line, obviously you're on the way to get set up. Actually, if you look for the two slides, it's actually instructions.
I think that one is one just put the it takes a while. But I think it's still complaining about that.
So when did this course start? When did this start?
We started doing it last year. Then we did about 24 weeks, and then we restarted like from scratch again. We had lots of people who were sort of in your. So we had a lot of people like you who kind of missed, and then by the time you get to kind of week 23, that's a lot to catch up on. So we started again at the beginning. Most of these guys,
Catching up 23 weeks, that's the
definitely.
So yeah, we restarted in May. It's fine.
it's okay.
I don't know why it's not.
Yeah, getting set up. Okay, so you've got so you need two things. You need C-line, which is also installed. You also need to install a C++ compiler.
Okay.
So if you follow those instructions, then that should get you all set up. Now, if you need any help, just ask.
No problem.
Oh,
Yeah.
okay.
Oh, no, just not feeling very today. I'll get through it and I'll power on through.
Do you want beer or something?
Definitely don't want a beer, but thank you.
Coffee?
I might, when we do the next exercise, I might go and get another coffee. Okay, so just a little progress check. Well, first of all, who managed to check out the code? I've got two hands up. Yeah, all right, most people. All right, who managed to implement operator not equal?
Yeah.
Most people-ish. What about operator plus and minus? Yeah, maybe. Plus and minus? Hands at the back? No? Okay, maybe I'll give you a bit longer.
Beg your pardon, I'm just going to go on the take
If we're going to do star videos, I definitely think installing C-line and the compiler would be the best place to start.
Yeah.
Yeah. Like before we do Hello World.
Yeah, I agree. I mean, that was just you know, like an example, just to have a feel for it.
Okay, here we go again. Right. So I've taken it outside now.
Mm-hmm.
I'm just passing the 1 point now.
Okay, so does that
So,
compile?
Well, no, it doesn't, because I can't. It still doesn't.
Okay.
It can't be a place which is and point. So I'm passing.
Okay, so if it's a free function, right? So the bit shifting operator takes 2 arguments. Takes a thing on the left and a thing on the right. So when you write your operator, it needs to have 2 arguments, 2 parameters, the left-hand side and the right-hand side. So, yeah.
That's easy enough to do.
Yeah. Now the one on the left is an O string, and the one on the right is a point. So for your overload, the first argument needs to be an O string, and the second argument needs to be a point.
Okay.
I did say this was hard.
Yeah.
Got there at the end.
It's one of those things that usually it's quite hard to do unless you've seen it before. Once you've seen it a few times.
Yeah.
But I thought it's actually
It's
a more it teaches you more to do it yourself, because it's something that beginners will just copy and paste it from something, or they'll copy it from the textbook and not really understand what it does. But if you have to think about what it's doing, that's my excuse for getting you to do something horrible.
Yeah, I mean, I definitely I found some code that was as close as it got, and then just re-implemented it. So I just grabbed that and re-implemented it for the. So I've got, so I did do some copying this. Yeah.
That'd be good. It's got to be a string. It's got to be a string.
A stream.
Stream.
Yeah.
Which is not the same as a. Okay.
Would you normally get the Scenic build?
Yes.
Yeah.
Yeah.
Sorry?
This exercise would be a perfect one to go into templates later on, where you just change like the type.
That's a good idea, actually.
This is like one of the first things that is kind of used, jumping onto doing a vector or list.
Yeah.
But yeah, how's that in the end of this course?
Templates, yeah. So one of the things we did when we it's like implementing a simple unique pointer, for example.
Yeah.
Just as an example of a class template.
That's also good. Simple.
And a couple of the simple algorithms like count. Oh, that was when we were doing sort of meta iterators. So doing like find and count and the simple ones.
Operator.
The operator.
Where it gets even more useful when you have another class that contains points, for instance, and then you can stream that point into it, and everything is just printed correctly.
See you later. Okay. Who'd like to look at the solutions?
No.
No? Not yet.
I'm having trouble implementing this. What's our? It's
Okay. Was your studio not found? So you need to set up a tool chain. Have you got Visual Studio installed?
I think so. I think I have actually.
Or did you download so that? So did you download the compiler from that link? And
This one here.
yeah. So you downloaded that. Did you unzip it somewhere?
I use this one.
Yeah.
Yeah.
Okay. So where that's saved, just if you find it, and just run the file. You want to run it. Well, if it isn't, then everybody here is in trouble. So. Oh, there you go. Norton says it's safe, so.
So it must be.
Well, maybe. Don't worry about that file. Just find where I'm at. Still not wanting to. Yeah, okay. So I'm just going to. Let's take a few minutes. But once that's done, then we can tell CPython to use this compiler that it's just installed now. And then it should, fingers crossed, be able to run hello world.
So you do these classes for free?
Yes,
Oh, wow.
it's all Tom's fault. It's his idea.
The complaints to me, all the thanks to him.
What we should do is like the drug dealer rules, like a couple of classes free. It's like, yeah, that'll be sitting.
Don't get any ideas. I don't look that similar.
And I had no idea about chemistry.
Surprisingly long-winded, this in time.
But it's
2:40. We're in time came up.
yeah. Oh.
No, I'm serious because they measure how fast your I/O is,
Yeah.
and then they like
It should just say about 3 minutes.
they should just average it. It's the same impact. So.
Yeah, it's not like you download something from the internet, you mostly get fairly consistent. Whereas this is decompressing, so simple files will be very quick to decompress. You were going to have three more minutes, now you've got 3.5 more minutes.
And counting
Yeah.
upwards.
3 minutes 40.
Wow. 3/4.
So is it every Tuesday you do it?
Every Tuesday. Yeah. Normally we're here. Sometimes this space is booked, so we have to go to other locations. But yeah, most of the time. So are we here for the next few weeks?
Yes, we are. I mean, the good news is I booked some of the classes, the space for some time. Let me just tell you exactly.
4th of September.
Okay, so the dates which we have are 31st of July, 7th of August, 14th of August, 21st August, 28th, 4th of September, 25th of September. 11th and 18th of September we'll have to find a home somewhere else.
Okay, but at least the next. So every Tuesday, 6:30 to 9. It's usually me during the classes. Occasionally, another guy who's usually here, who's upset tonight. He takes some of the classes as well.
And where does filming come involved? Because you said you can find the film on YouTube.
Yes, so we record all the sessions.
Is there hidden cameras?
No, not on the camera. It's just I'm being recorded. We're being recorded. I've got a microphone in the computer, and the slides are being beamed. So we're actually live on the internet right now. Hello, all 3 people on the internet. Yes, and all those live streams get recorded. Are you watching for questions on the internet, by the way, Tom?
Sorry?
Are you watching for questions on the YouTube stream?
We are covered actually, because we have the guy who got the man flu on the other side.
So, not doing very well today. So this is where I've got so far.
I would love to say no, but it's what it is. Oh yes, it's probably better to us, these guys. I've been doing it for 10 years, so...
Two things wrong.
Two things wrong. One is the left-hand side of the screen shouldn't be, this one shouldn't be constant.
Okay.
It has to be mutable because you're changing the state within the screen.
Oh, okay, right. I'm changing what I'm printing.
Exactly. And then you have to return also something from the function.
Yeah, which I thought was an OS, a return stream.
Yeah, you return the same argument actually. So if you do a return OS in the end.
Oh, okay. Oh, sure. Yes.
So far so good. There is actually one more.
I don't need this here, do I?
You do need that
I
one,
do.
but
Okay.
it has to change a little bit because right now, what happens now is that you always operate somewhere, right? Where you can do your point and
Yeah.
the string thinking. Right? So it comes into this operator, but on this first line, it does the same thing. It takes the string, then it takes the point, and it calls the same operator again. So we call yourself indefinitely. So it will compile, or once you run, it will crash.
Yeah.
It's stacked.
Yeah, that was where I was getting stuck.
You're exploding the stack. So what you want to do is you want to print the x value, and you want to print the y value from separate, right?
Yeah, which is here.
Yeah.
So is it just OS equals
So if you get dot x over here, for instance.
dot x? Yeah.
Now it will print out only the x value.
Yeah.
Whereas
Yeah, and another.
I'm sorry.
Yes. This looks correct. Because now it will print the x, and then it will print the comma, and then the y, and then your line. And then this is the magic part. Since it returns the reference, these operators that you call here,
It's returning OS.
is
Yeah.
itself, right? That allows it to do this chaining of operators.
Okay.
So, for instance, here, it calls O string operator with an int, right?
Yeah.
On this first one. And it returns the string, and that string is put in the next operator, which prints the string. And that one returns the same string, it goes into this one,
Oh, I see.
so it's kind of like this chaining the operator multiple
Yeah.
times.
And does it? I mean, I'll put that in just because I put it in. Does that need that to be there? When does it know it's finished?
I wouldn't put it there. I think it should. I think that's something that should be done by the caller of the operator. I would put it like that instead.
There's a lot of waiting around.
There's a lot more to this.
The more advanced you get, the longer you have to wait. You do really advanced stuff, the compiler takes forever to actually compile it.
That was
Operator
So yeah, you compile it. So whenever you make a change, the compiler comes. Once it's compiled, then you can run it however many times you want. So yeah. So languages like Python and JavaScript, you don't have that separate compilation step.
If you check your header
You have
file,
the source code, you
then
compile that
there is
into a program.
you go to
run,
point.html.
but then you can just run that.
Now the header.
It can take a long
Oh,
time.
I need an IO string there, do I?
No, but you need to remove the const.
Oh,
Yeah.
yes.
So the advantage is that
Yeah.
once you've done that, then running the program, the program should run fast. Equivalent. Or usually run fast.
Oh.
You're not going to get there.
Okay, thank you very much. There's more to that there than I thought. Changing it, I didn't
Build the
get.
program.
Yeah.
It's just it's the first time it's running.
Okay.
Usually,
Something to think about.
usually when I do those kind of like points or vectors, I can also print like a bracket
Okay.
beginning and end. Because if you print multiple points, you want them to be grouped together.
Okay.
Okay, ladies and gents, we're going to move on, otherwise we're not going to have time for anything else tonight. So, no, there should be 2 branches. Okay.
So the stream
Yes, it is, yes.
You're going to share that or?
I am going to go through the solutions right now.
Oh,
Okay, so this is, if you want to look at this, by the way, in the original repository, there's now a branch that's EX1 solutions. You can just use the little drop down at the top to change to that. I'll put this on super huge, by the way. Can you read that at the back? Or do I need to make it? I'm not sure how much bigger I can make it.
is this already on?
So yes,
So we got full edges.
so just probably easier just to look at it on the website. It's the EX1 solution branch. So like I say, if you go to the repository before, and then there's this little drop down.
One thing, it works.
It works. Awesome. Okay, so now we have struct point that we had before. Oh, can you just make sure you can see this on the internet? Yeah. So we have our point, it's got the two members it had before, and now we've defined two of our member function, two of our operator overloads as being in class. So the plus equals and the minus equals. The reason for that is because these two have to be member functions because they modify the thing. Do they? Do they not? Oh.
You can do them outside.
Oh, well, there you go. I learned something new today.
But I would say that it's good practice.
I think it's better form to put these these two as member functions because conceptually they operate much like the assignment operator does. In fact, they are kind of forms of assignment. So operator plus equals takes one argument, or as a member function, it takes one argument. So remember what we said. As a non-member, it would take two, the thing you're operating on and the thing you're adding. But because we're now defining these as member operators, the thing on the left has been decided for us. So this argument, const point reference other, that's the thing we're adding. The thing we're operating on is this. So this operator needs to return a reference to a point, a reference to the thing we're operating on. And the reason for that is that, and it's very silly, but it's what ints do, and it allows you to chain assignments together, which is probably not a very good thing, but it's sort of established now that that's the convention. You could just return void, and in a way that might be a more sensible thing to do because you rarely want to do I plus equals j plus equals k plus equals whatever on one line. And if you return void, it would prevent you from doing that. But ints return a reference, so for consistency, you usually expect the plus equals operator to return a reference so that you can chain things together as well. But we'll talk a bit more about those in a moment. Let's have a look at the other operators. So this one, equality, that was already provided for you. The declaration of the others, of not equals, is exactly what you would expect. The declaration of operator plus. So I could have done this as a member function. I chose to do it as a non-member, as a free function. So this returns a new point. Notice this isn't a reference. It returns a new point. And it's the same with operator minus. And then the thing that a lot of people got tripped up on is this O-stream operator. So if you think about what you write standard cout, arrow, arrow, point, or thing that you want to print, right? So it's the arrow, the double arrow has two arguments. The thing on the left is cout, which is an example of a standard O-stream, and the thing on the right is a point. So we need to write an operator arrow, arrow that takes two arguments. The thing on the left is a reference to an O-stream, and the thing on the right is our point. In this case, we're taking it by const reference because we don't need to modify our point. We don't want to copy it either. In this case, point is quite small, so copying it wouldn't be harmful, but it's good practice.
Would it be copied here?
No, this won't be
Oh,
copied.
yeah, sorry, yeah.
And again, the convention for the streaming operator is that we return the first argument. And again, this is to allow you to chain things up. So you can do ostream, arrow, arrow, thing, arrow, arrow, other thing, etc., etc.
So if I tried to chain something on the end of mine, if I hadn't done that, then it would break.
So, this is huge. So let's have a look at the implementation file. So first of all, the equality operator is exactly what we had before. Operator not equals. Now, this is the only definition of operator not equals you should ever need. The only thing it should ever do is the opposite of what your equality does. So always define it in terms of your equality operator. Do the work in your equality operator. This is the only not equals you should ever need. I mean, you could just implement it doing the opposite of that.
Not equals or not equals is what it is.
Yes.
Yeah.
Which is, it's perfectly fine. I mean, it's correct, but this is shorter and you'll never get it wrong.
Yeah.
Would it be an advantage of actually implementing the other way, as you said?
No advantage at all.
Just longer code.
I think there's like some special case.
Well, maybe Richard knows different. I have never come across a situation where anything other than that.
So all of these operator overloads can basically see the ones that came before them.
Well, we've declared them all in our point header, and then we've included this header. So it already knows it's seen the declarations.
Yeah, but I mean, when you're using one in the file that we're declaring them in, when you're using one in another one. So
okay, so this bit here, this doesn't need the definition. It only needs the declaration. It's like calling a function. So even if we'd reverse the order of these two in this file, it wouldn't matter. It would still work.
Right.
Because we put the definitions in the header. Sorry, the declarations in the header.
And got it.
Okay, so that was reasonably straightforward. Let's have a look at operator plus. So as we said, it returns a new point. It takes 2 points as arguments. Again, a const reference because we're not modifying either of the points. And again, I've done this in one line just because I like to be fancy. So we're declaring a new point, we're returning a new point, and we're initializing it with the x-coordinate of the left-hand side plus the x-coordinate of the right-hand side, and on the other side, and as the y is left-hand side y plus right-hand side y. Does that all make sense? And then exactly the same for operator minus. The only thing with minus is you have to be a bit careful about getting the order of the operations the right way around. Right? Because here it doesn't matter whether you do right-hand side plus left-hand side, but it does matter for subtraction.
And the curly brackets will work there like that as long as it equals the number of data bits in your struct.
Yes. So as we're going to talk about in a minute, we're going to talk about constructors. Point doesn't have a constructor. And all its members are public. Again, we're going to get to talk about that. So you can use this funky curly bracket syntax. It's what's called an aggregate. Okay, so this one was a bit more complicated. Operator plus equals. So what we want to do in this case is modify. It's a member function. So that's why it has this point colon colon at the beginning. So this is, in case you didn't see it last week, this is how you would define a member function out of class. So it begins with point, so it says this operator plus equals is a member of point. It returns a reference to a point, and it takes as its argument const reference to another point. So we've got this x. Remember that this is a pointer, so we have to use the arrow to access its members. This x plus equals other dot x. And the same for y. So we're adding x's values to our own x and y. And then we return, this is a pointer, so we have to dereference it. We get it, this returns a reference to ourselves, which is what we return. Again, it's convention to allow chaining. Whether or not it's a good idea, I don't know, but it's the convention.
Why is that a return necessary?
Sorry?
Why is that a return necessary?
The return is necessary because it's not a void function. So anytime we have a...
Why do you decide not to use a void function?
Oh, so this is what we were saying earlier. The convention is so for your assignment operator, which again we're going to talk about assignment operators in a moment, but for built-in types you can chain assignments together. So you can say I equals j equals k and chain all the way through. And so because we want to mimic what the built-in types do, we replicate that for our own types. And the way to do that is to return a reference to ourselves. Sorry?
So you can keep on going.
Yeah, so you could in theory do P1 plus equals P2 plus equals P3 and do that all on one line. Now that's not necessarily a very good idea to do, but it is as I say, it is the convention that if you're writing an assignment operator, and this is a form of an assignment operator, that's the convention.
So basically all overloading operators of the one chain, you should return this.
Only the assigning ones, I would say.
Interesting. Maybe I can't remember. Maybe I'm missing something. But
Yeah.
we are returning a reference to a point.
Yes.
But how do we prevent that we're not returning garbage? Because once we hit the scope operator, that's being destroyed.
What's being destroyed?
Well, this pointer.
What is this?
Yeah, it's a pointer to. So it's basically a pointer which is outside of that scope. Yes.
Yeah.
Okay.
Yeah. So within a member function, this is always valid.
Okay.
So returning a reference to it is, in this case, is safe.
Okay.
We know that this is not going to go out of scope.
Yeah, I thought there is a way, but I couldn't.
No, I mean, it's good intuition to be worried about returning a reference.
Yeah.
But in this case, we know that the lifetime is controlled outside. So
Okay,
that's fine. So it's good. It's good kind of intuition to see that you're returning a reference and like, alarm bells are ringing. That's good. But in this case, it's
is that the part of code smell? Like if you see, the return of reference.
it can be in some cases. Yeah, it's worth looking at it and making sure that you're not doing anything silly.
Okay.
Okay, so that was operator plus equals. Operator minus equals is exactly the same. This time I didn't bother doing this arrow because we don't need it. I only put it in there just to show you what it would look like. So we can just do x minus equals other dot x, so that this arrow is implicit here. But otherwise it's exactly the same. And for the streaming operator, well, we talked about the declaration already. So the left-hand side is a reference to this standard defined class, which is an O stream. And on the right, we have a reference to a const point. And again, the convention so that you can allow chaining of these things is to return the first argument. So we've got an O stream, and then we use the arrow operator, so we give it, you could have done this any way you like, but I did it so you have a bracket, the x value, comma, the y value, and then a closing bracket. So it's written as x, comma, y in brackets. And then we return OS, return this thing, OS, O stream, return the thing we were given. So again, your question about lifetimes, we're returning a reference. Well, in this case, it's a reference we were given. So the danger of returning references is if it's a reference to a local variable. So a variable that you created inside the function, if you return that, return a reference to that, that's bad. But in this case, it's the same reference we were given in the first place. So something else is worrying about the lifetime. We could only receive that reference if it already exists outside.
And that cannot be const. Because we are modifying that.
Because internally, this will modify the O stream internally in some way. It'll, whatever it will do, move markers around and copy things to the operating system. However it works internally, it'll probably fill a buffer, in fact. It has to modify the internals of the O stream. So if we had made this const, it wouldn't work. The last thing I asked you to do was just to test all these things in your main function. I won't go over this in great detail. I already had this test for operator equals equals, I think. I wrote a corresponding one for not equals. Is everyone familiar with the Asserts Macro, by the way? I did cover it a few weeks ago, but it's...
Why? So that means no.
It's a sort of magic function that tests whether something is true. So it tests whether P1 not equal to, in this case, P1 not equal to P2 is true. So P1 is 1, 2. P2, oh, shouldn't have put the equal sign in there. P2 equals 3, 4. So if P1 is not equal to P2, which we hope is the case, this will return true, and that'll be fine. If the test failed, so if this was false, then the assert would fail and our program would crash there and then. And then, well, why is that a good thing? It's because when it crashes, it'll tell you the exact line that it failed on, and you can go and you can look and you can see what it does. And if you're using a debugger, your debugger will stop there and then, and you can look at the values of your variables. Assert is a very useful function.
Is it something that you just use in a program, or is it something that you use in TDD, or use something else for TDD?
It's a sort of very simplified version of what test frameworks do.
Yeah, that's what I was thinking.
Yeah.
I wondered if it was actually what you use, or if there are test frameworks.
So test frameworks, things like Catch and Google Test and those things, they will implement their own, usually macros actually, that do similar things, but usually a bit more sophisticated. Assert is a very blunt instrument.
Yeah,
right?
It doesn't tell you anything if passes, does it?
No, and in fact, the advantage of Assert is that you can put it in directly in your code. Whereas usually a test framework, you'd write external tests.
Yeah, exactly. Yeah.
Right? Whereas the Assert can go in your code. The other advantage of Assert is when you compile in release mode, so when you tell the compiler to put all the optimizations in, and when it does that, it really messes about with your code and will change things all over the place. All the asserts disappear. So there is no, in release mode, there's no performance implications of assert at all. So assert, yeah, it's a blunt instrument. It's not a replacement for a proper test framework, but it's kind of a useful thing just to make sure you're not doing anything really silly.
It's really useful for QA builds, for instance. Prepare the debug build and QA. And then the tester is testing it and it finally crashes. It will get the crash.
So what happens with the assert when you do the release mode? Is like strict like somewhere else?
No, it literally just disappears. So assert is not. It looks like a function. It's actually implemented as a macro, preprocessor macro. So that means that the compiler never even sees it. It's removed from your code before the compiler even gets to work. It's magic. Yeah. Okay. That was the first exercise we're probably not going to cover all of the rest of the material tonight. But never mind, that's okay. Because we're here to learn. And if you learn something doing that exercise, then that's good.
Never got that OS stream. One of those.
No, it's one of those things that you have to be shown, right? So what I was trying to kind of guide you to was trying to understand why it does the thing, rather than just copying and pasting. This is how to print something. Kind of wanted to guide you to understanding exactly what it's doing. That you're overloading an operator, the thing on the left, the thing on the right.
So basically that.
No.
So something handling. I have this thing handling of this values through existing office.
Yes. Exactly that. Okay, so should we talk about special member functions? We talked about ordinary member functions, now we're going to talk about special ones. Not magic member functions, they're not magic at all. In fact, I'm about to demystify them completely. Hopefully, maybe, fingers crossed. The first few weeks of this course, I absolutely drummed into you about how brilliant C++ is at destroying your types at exactly the right time. Right, so things go out of scope, it's destroyed. Right, and I went on about copying, value semantics. Do you remember I was banging on about that for about the first 3 weeks? That's why half the people have disappeared since then. Probably. So, constructing types, copying them, destroying them, these are really, really fundamental operations. And we can write special functions that are invoked when we create a type, when we copy it, and when we destroy it. The constructors, assignment operators, and destructors. And these are the special member functions. Technically, not all constructors are special member functions, but. And why are they special? They're special because, for the most part, if you don't write them yourself, the compiler will generate them for you. Right, so every struct, every class, every struct, the same thing. It always has a destructor. If you don't write one yourself, the compiler will generate one for you. For example, most of the time, unless you do something special, most of the time you're going to get something called a copy constructor. We'll talk about that in a minute, which is a function that gets invoked when you create a copy of your struct. So these are special functions that are almost always there, but you can choose to do them yourself if you have special requirements. So let's talk about constructors, because constructors are the ones that you'll write most often. If you have any sort of non-trivial class, you will almost always want to write a constructor for it. So a constructor is a function that runs when we create an instance of that class, of that struct. I use the two words interchangeably, by the way, just to try and reinforce that they are the same thing. So constructor is a function that runs when we create an instance. And we write a constructor by writing a member function that has the same name as the class. So if you've used Java, for example, it's exactly the same. C#, I think, does exactly the same. So a constructor's job is to make the object that we're constructing, make the new object ready for use. So it needs to set up the member variables. It needs to set up any base classes you might have. We're going to talk more about base classes next week. It needs to, in the terminology, establish the invariants of the class, if you really want to get fancy. So syntactically, constructors don't have a return type, and you can't declare them const. It wouldn't make much sense to have a const constructor, because how would that even work? So what does it look like? So we've got a little struct example. And now we've written something that looks like a member function, but has the same name as a class. No return type, there's nothing here. Not example, it's not void, it's not anything. There's no return type. Has the same name, and in this case it takes two arguments. An int I and a float f. And this is a declaration of a constructor for our struct example. Yeah?
When we use the plus operator, does it basically call the constructor?
Yes. Yeah. So the plus was creating a new instance. So if your class has a constructor, whenever you create a new instance, it will use the constructor. Oh, well, that's fun. So just like a normal function, normal member function, we can declare a constructor in the header and define it later. Define it in an implementation file. You can separate the declaration from the definition of the constructor, just like you can with a normal member function with a normal free function. Again, constructors can be overloaded, so we can have multiple constructors which take different arguments. Okay, so again in C++, we can have function overloading, that is we can have two functions or multiple functions with the same name but different argument lists. And we can have multiple constructors that take different numbers, different types of arguments. In particular, one special case is if we have a constructor that takes no arguments at all. That's called a default constructor. And the default constructor is one of the special member functions. If you declare no other constructors yourself, you're going to get a default constructor. The compiler will always give you a default constructor. Yes?
If the default constructor is the one that can call without passing any arguments, not one that doesn't have any arguments.
Yes. Yes. So the old man in his armchair at the back has corrected me. I said if you have a constructor which takes no arguments, it's a bit imprecise. I've always pointed out if you have a constructor that can be called with no arguments, because in C++ functions can have default arguments, default parameters. We covered that way back at the beginning when we first introduced functions. So if we go back a bit further. If we look here, if I said int I equals 0, float f equals 0.0, so if I gave them both default parameters, then we would be able to call this function, be able to call this constructor with no arguments. So in that case, it would count as a default constructor. Thank you. That was...
Well
you're not welcome anymore, but no, that was good. Thank you.
Well spotted. One beer.
So default constructors are a bit special. If you don't provide any constructors, you will get a default constructor for your class. And all the default constructor will do is it will call the default constructor for each of your member variables in turn. Okay? So if you've got a class, I don't know what it is. Let's say a class student, and it has string first name, string second name, as its two member variables. Your default constructor will just default construct both strings, and the default constructed string is empty. So all the default constructor does is call the default constructor for its members. So next question is, well, what happens if you call a class if one of your members doesn't have a default constructor? Because you don't have to have a default constructor. So what happens in that case? Well, in that case, the compiler-generated default constructor is not going to be implemented. It's going to say no. Well, if you try and ask it for one, it's going to say no, I can't do that for you. Sorry. We can we can ask politely we can ask the compiler to generate a default constructor for us by using this weird equals default syntax. So most of the time, if you write no constructors at all, you'll get a default constructor. But if you write your own constructor that takes some other arguments, that will stop the compiler generating the default for you. But you can bring it back. You can bring it back into life by using this equals default. So here we've got struct example again. In this case, I've written a member function that has the same name as the class, no return type. So this is a constructor with empty brackets. So it takes no arguments. And now I've said equals default, which is saying to the compiler, please provide this for me.
So can I use the equal default as well with the constructor that's not like with empty?
So if I'd said example int I in there,
I wouldn't like that.
because it wouldn't know what that means. It doesn't know what you want to do with the argument.
Even if it's like int I equal, I don't know, 0. So
No, that wouldn't work either. It has to, for a default constructor, it has to have an empty argument list in order to request the compiler to generate it for you. So this is how to get the compiler to generate one for you. But we can do the opposite as well. We can stop the compiler giving us a default constructor when it otherwise would. And the way to do that is, instead of saying equals default, we say equals delete. So here we have struct example empty brackets. So this again is a default constructor because it has the same name as the class, an empty argument list. But now we're saying equals delete, which says, usually you would generate this for me, but I don't want you to. Please don't.
What circumstances would you use that under? Because that would mean that you can't instantiate anything if you just...
Well, in this case, no. But if you had some other constructors, yeah, it's not very useful for the default constructor. But this equals delete is more, it can be used on more than just, in fact, you can say equals delete to any function.
Okay.
Yeah, so
I know one example where the default constructor could be deleted. If you only want the type to be like a tag type,
okay.
then that's
Deleting the structure again. Yeah.
You have a stop.
Sorry?
You click on the stop.
Maybe. We'll see. We'll see.
magic.
Is it a generally good practice to do these sort of things? To play with the compiler to say, oh, generate me a default constructor, or don't generate me a default constructor and that sort of thing? Or is it, I think it's probably better just write the constructor very diligently and call it with the right parameter values, right?
It's a good question. So the question is, what's better practice? And the answer, unfortunately, is it's complicated. Does it make sense for your type to have a null state, an empty state? So for something like a point, a reasonable default value would be 0, 0. Right? That's a kind of reasonable default value. So it would be reasonable to have a default constructor for our point that initializes it to 0, 0. So in that case, we would say to the compiler, yes, please generate me this. But it also makes sense for our point class to have a constructor that takes 2 ints to supply the x and the y value. And if we wrote that constructor, we would inhibit the generation of the default constructor unless we specifically requested it back again. still sounds a bit complicated and weird, doesn't it? Never mind. You're going to have a go at it now. Oh, sorry?
Is this on the readme again?
It will be in about a minute. Yeah, this is. I'm sorry we ended up in a room with a very small screen. It's much better when it's all beamed on the wall in. So I'm just going to take this off the screen for just a second so I can copy and paste it. Sorry about this. I'll tell you what I'll do. Oh, that's fun.
Has it struct called line?
Yes. Okay, if you look at the README now, it should have this tagged on the end of it.
In the meantime, as well, if everybody puts their name on the paper, it's going to be included in the head count.
Oh, sorry. That one. Oh, I can. There we go. It's got a little bit of formatting now. So if you remember in C-Line, you can ask it to generate a new files for you. If you go to the, I think it's this file, maybe I can't remember exactly how to do it. You right-click on the project.
They're in the same folder.
Yeah, so I've got line like name and contact.
And there's nothing in this.
Oh,
That's an item. Probably. I don't know. Re-emerate.
on my favourite idea as well.
Yeah. It's so much faster. I can see right
Do it in context as well.
Yeah, if I do, yeah, I know. But I'm actually getting surprised I'm doing like better code. Maybe
No vector operations, are there? If we were iterating over a vector of points.
I probably need to set index.
See, are you coming tomorrow?
I'm going to try.
I won't blame you if you go home today. Right. So see you next week anyway.
So it's project files. And it's memory project.
Okay. Yeah, that's fine. So are you trying to do the project from the last?
Yeah.
Okay. Sure. So did you clone the project from GitHub? If you go to the so the clone will download and we'll so there's a lot Git installation. So you need, I don't know how familiar you are with this.
Not on Windows. I've got Linux. If I try to put my Linux on, it doesn't work properly because the Linux cancels
No, I'm seeing you looking at Netflix. I'm like, hey, it's good.
Last night it was like 14% down.
You have some investments in them.
Okay, this is really weird. So if I can't, I need to include my point. If I don't include my point,
Okay, no,
I can't use it. So if I do include it, everything just, I don't know what that means.
So you're going to clone it.
But alright, so because of this stuff, it's already defined inside of the pointer basically. So either we can change it to line.
Window.
Oh yeah,
Alright,
we change this
so
one
now,
to line.
these are all files.
And
That is what you began with. So now,
Okay.
do this thing.
Now I can do that. So, never got
But again, once it's finished with this, that will green the arrow should light up. So you just press that and make sure it's working correctly. Come back and help you to it. You done?
No, I don't. I'm not sure.
Ah, okay.
This is not.
You were sitting back
this is-
doing that. I thought,
No,
this is easy.
This is perplexion.
Perplexion.
Right.
Better. Better.
Right.
Oh,
So,
Alright, so
add a line the struct to the project from last
Yeah.
exercise.
So yeah, that's
okay.
Two member values.
There are two member variables of type points.
Point.
Name, start, and ends. Okay, perfect.
And
Add a constructor.
line. Yeah.
Okay.
So I put them all.
So let's forget about that bit for a bit. For a minute.
Okay. Yeah. And
So
same,
let's.
the same.
We won't worry about
Add
adding
those
one
ones.
more.
Okay. Right.
So that's correct syntax for
The
constructor.
thing is that
Yeah.
So point start, point end.
Yeah.
Now, the thing is, you've tried to write equals
and
default
especially companies that has any
for something that's usually not a default constructor. That's it's not going to run.
I don't know if that
Right.
affects it.
But if you just do that,
Right.
that is a perfectly fine definition
Like the majority of businesses.
of a declaration of
Comes
constructor.
first.
Yeah. Okay.
It's complaining that it's not implemented.
Sure. No,
So-
I haven't done it on CPP.
So just have a go at doing that in the CPP file. You can actually, I think you might be able to right click it and generate.
Because of this.
I should be able to
Because
see
everyone
it.
that was logged in,
That's inside the comments.
all those tokens.
Now this, because it's
The
the new struct, it doesn't have to be inside.
and user doesn't
It can be outside.
Okay.
Yeah.
I don't like it.
No. Okay, so
Function starts.
let's
Yeah,
how do we
yeah,
write
yeah,
member
yeah.
functions? Well, write the external definition.
Has to be,
You
has to be,
have to put
you
that.
have to put it inside there. So it has to be,
Oh.
has to be in the,
libraries, I think.
has to have a line into it.
Exactly. Perfect.
This doesn't work.
Yeah.
All right. Okay. Cool.
But now we have to actually write the definition of it.
So the thing is,
And this is where we come in to the next one, is it?
Yeah. So initialize your start and end members using the two arguments you've just been given. Yeah.
So I've given point start and point end.
Yeah.
So it starts.
No.
Now they have a game.
Don't think I need that. It's a bit just.
Well, do you remember what I was saying about if you have a function whose argument names are
Yep.
the same as
On
member
favor.
variables?
Yes, I
It's
remember you
still
making.
the same, but it's
You
another
need
different
this.
Yeah.
Oh yeah, but because you don't use the point.
Yeah.
Okay.
Oh,
No,
okay.
no one reads from the
It's a
point.
point, so it's got to be.
Well, no, because you want to
Okay,
set it
that's
equal
fine.
to this.
That's
Sorry,
fine.
to the one you've just been given. No?
So I've done.
Yeah, but if I've defined it as a point, it's two. It's two.
Yeah. There's no one that calls
Yeah,
that
but you
structure.
can just assign it all in one go.
And that's one.
But then
You can just do.
Oh,
Place
okay.
this
So
point.
it's given it. It's actually
Yeah,
zero
you can
from
just
zero.
yeah, it could
No,
also
no.
be.
So you want to what you want to do is to say
Always
this
the
dot
most
start
clever.
is equal to this one.
I wouldn't mind that.
So you do
Brilliant.
this arrow
Oh,
start.
sorry,
equals
because
start.
it's a different start.
Yeah.
Right. Yeah.
So that's why I say it's usually a bad idea to give them the same name.
Yeah. Yeah. Okay. So and then we do the same. Yeah.
Yeah, you, maybe better just to change the name of these things to other start and other end.
Yeah. That's true.
Otherwise it gets a bit confusing to which
Yeah.
start you're referring to.
I don't know, you get that, showing them around the structure.
Yeah, I don't really want to go climbing over the table.
Another one there, it's just as
Okay, I'll take part of this rest.
Oh, but I don't know how to.
Yeah, this really is a great awkward room to use. You guys have been really quiet. So either you're finding all this really easy, or finding it all really hard. Or it's alright and you're just quiet.
You can find the same way you get to with the points. So you can do the brackets.
Oh, wait a second, yeah.
But instead of
that,
that, and then I'll put 2 point and then just bracket as E1,
Sorry?
So what I'm going to use is
Yeah, that's fine. So now we've had a constructor which takes 2 points. Use this to initialize your start. Okay, so this is a fine declaration of a constructor. Is this defined?
this was the I don't have to worry about this.
Okay.
I feel like it's the separation between the default and the constructor.
Okay, so what's the default constructor now?
I always have trouble with it.
Well, that's confused you a bit by saying you can have. Well, you actually want that. That's what I was after. So, default constructor is one that takes no arguments. And if it takes no arguments, then we can use this equal to fit.
And then define the 0, 0 thing. And,
Well, no, you've already done it. So you've actually jumped ahead several
I know,
steps without even
it's
realising
fun.
it.
And when you declare this like that, surely you can't do that without so you can't say without having this and then just
No, if you didn't have these things are called in-class additions. So
There is
didn't
an
have those.
easier way to fix this.
I
just get rid of them. Yes.
Get
rid of those two lines.
Right.
And,
If you didn't have those
in the beginning of the file.
So
On
in
the
that
top,
case,
before everything else.
okay, well, I suggest as next time,
Go
go ahead and try and implement this first constructor, and then we'll worry about the default constructor.
And space. Okay. Once. That's it.
or no, actually make a new class called y.
You, just for quickness, you could do it per time.
Yeah.
So, so try and implement that constructor.
That's interesting.
Yeah, but if you want to find change your operator stream. So add parentheses
It's all done.
before and after.
Right.
Yeah.
So you can see which points are actually printed.
Working. Awesome. Right, so at this point, do you want to jump into this exercise then? Or is this going to be a bit?
Yeah.
This is a bit advanced to start.
Yeah.
Isn't it? Okay, so
Bundle up. P4. P4 first, then you print
we're
yeah.
jumping a month ago.
Now go home.
Yeah, because I printed that. That's what I printed.
Okay, so in C-Line, create a new project.
Yeah.
Yep.
So if you want C-Line,
Yeah. You get this one here, and
so let's file new project. We'll call it.
I would actually do the so you copy the operator from the point to the line, change it to the line, and print out the line break.
Window.
Oh, I see what you mean. Yeah. So just
So then the operator, all the points operate through, that's the copy.
And then what was the next thing? Create a new source
Okay.
file. This was .cpp.
So in point.cpp, so I take this one,
So
Yeah.
the operator overload.
Copy that
Is it because I'm using CL?
one. Instead of point
It doesn't matter.
Yeah.
I don't know. Yeah, it's because it's using C-Line. I don't know why C-Line takes quite a while to think about it how first consider it.
Yeah.
Sorry, just 2 seconds.
Uh,
So,
yeah, L
so
dot
here
star.
are the struct, the start,
Yeah.
and here is the blah. And then, so let's say if I do this, right?
Yeah.
And then if I
Yeah,
do
so then
this,
copy from the header file.
and this two lines, the compiler is
So
Should I
Music
yeah, you just do it that way.
And then you get like
You change your glasses.
if you print two lines, there will be.
It does seem to be good. It gives you like hints about what.
Or I could do it in like a square bracket.
It's sort of easy to understand.
That would be fine. Yeah. And now you're saying line equals defaults.
Yeah.
Yeah, also it's like line equals and as parentheses and have a point in there.
Yeah.
I don't know if it is.
So,
So,
the trouble is,
sorry, you were saying.
I don't know.
From
It's like a simplified.
Yeah.
So if we do that,
And then we'll
Now if you go back to your main, and then you should be able to do new line. The first version started.
There is no default. So when we said that if you just did int now it should be like curly brackets.
Experience. So I didn't give you
Python, C, C++, I have no idea.
It's a different story.
I'm declaring your exit. There was a place where you have to declare your exit.
So just go back to the line where you have something and stuff.
Oh, right. Oh, I can see doing it automatically.
It should be giving default constructor automatically.
I like this.
So if you
I'm just I'm just used to it.
Yeah, I'm just very confused as to what equals before.
No, it's. I mean, some people say that before because I just. You know,
How's it going?
I'm
not sure. I'm really not sure.
Right.
I'll have a look if you want.
You know what I mean? So if that works.
It's a bit hit and miss with this, but so anyway, so
Yeah,
just to help me out with this. So the first one, okay, the first one, add a line struct.
Yeah.
That's that. I got that bit. That's not so bad. Right, the line you has two member values. Start point.
That's fine.
And then add a constructor line which takes 2 points. Use this to initialize start.
Yeah, it was looking at me.
Flip over to
There's a lot
here.
of people that come from Java and
Use the switches. Line.
Your
Takes
no.
Yeah.
two arguments.
Brackets.
And then
That's
define.
brackets.
No, but
Is that the wrong way around?
yes, you have so
That's what I wanted to check.
except so
If you do that, well, you just press space as much as it gets confused.
For Python.
so sorry, when it comes in
It's
there,
Yeah.
the inside,
it's called
it's the one that capacity to the line, right?
Meaning, yeah,
And you want
meaning exactly. If you instead
your
of
member
doing
variables,
just
start
you just do like
as long as the spaces are equal,
Okay.
you won't have a problem. If you could
very
add
lowercase.
and your next
sorry, I can.
That's
It's
really
strange. I
not
can't work out why it's doing
I think I was really because I was trying to learn it on my own,
Ah,
and when that happened, then I don't know what's going on. Yeah,
Okay.
because in my Python spaces are important.
Yeah.
Really important spaces.
yeah, it was like you said.
Okay, so that was.
Are we finishing? That doesn't make sense.
So that's the default structure line sets both to 0.
Tell me when.
We couldn't write it.
Okay, ladies and gents, we have to wrap up, unfortunately, because it's 9 o'clock and they will kick us out very shortly. So we'll pick up from where we left off next week because we've just started talking about special members and now we have to stop, which is a shame. But we will talk about them some more next week. By all means, if you want to finish this as homework, that would be great. And then we can start talking about copy constructors and destructors and assignment operators and the rule of 3 and the rule of 5 and the rule of 0 and public and protected access and all those fun things next week. But otherwise, thank you for coming and hope to see you next Tuesday. No, wait.
Next Tuesday, yes.
Yeah.
And for just as well, short reminder, tomorrow is C++ London. Here. One of the bigger rooms, hopefully. And this guy will be talking, so you're very welcome to come. There is still space. And for those who want to go for a pint, you're very welcome to go to Bierschenke. I'll go there, I won't stay very long, but I'll definitely be there. So you're very welcome.
Thank you.
So we need to call the line. That was really